Hello everybody, I want to take a look really quickly at how to access these tables that are referred to in the PowerPoint presentations. Table A2, Table A3, and the way to find them is in MyMathLab. Since you don't have a physical textbook, you can't just flip to the appendix at the back of your book. But if you go into MyMathLab from our home page, you can go down here on the left side where it says e-text content. So if you click on that, you'll see a chapter by chapter. So you can use that then to read each chapter. If you scroll down to Appendix A, this is where those probability tables are. So it brings up this link to tables and formulas, and it'll take you now to these tables. So I'm going to just show you really quick how these tables work. It takes a little bit of time to load. There's a lot of information here. So this is just saying if you had a physical textbook, it would be page 777. So this is the binomial probability table that you could have used. Technology works so much better for calculating binomial probability, so we didn't really use that one. But if we go to the next page, this is table A2. This is the negative z-scores. So the body of the table here shows you the probability. The z-score starts, the first two digits are on the left side, third digit's on the top. So let's say your z-score is a negative 2.35. So you go to the negative 2.3 over here on the left, which tells us we're working on this row here. Oops, it won't highlight for me. That's okay. And then we do the 0.05 up top. We come down, and here's the probability, 0.0094. So the probability, now remember, this is always a left tail probability here. So that's saying the probability of being less than negative 2.35 is 0.0094. The probability of being greater than would be the complement. It would be 1 minus the 0.0094, which, if you did the subtraction, would be 0.9906. If we go another page, this is going to be the positive z-score table. Now, this is where we find our critical values. It's like and you notice there's stars in the table here. This star is for 95%, a confidence interval. You see this is 0.9495, this is 0.9505. Well, 95% would be 0.9500. That'd be right in between the two. This is at 1.6, and up here, 0.04 and 0.05. So we just go right between those, which would be 0.045. And you can see down here it says, for 95%, that critical value is 1.645. For 99.5%, it would be right here between 0.9949 and 0.9951. Again, that gives you the 0.9950. And over here, there's other critical values for other confidence levels. So for 99%, for 90%, it's the 1.645. Remember, that's why you had to look up 95% probability. 5% gets split to each side. For 95%, you're looking at 97.5 or 0.975 because it's half of that remaining 5% that gets split. That ends up being a 1.960. It's actually 1.9599, so rounds to 1.960. The 99% is there. So those are those tables for normal probabilities, or z-scores. Flipping over, one more page should bring us to the t-distribution table. And all of this gives us critical values. And notice along the left side, you have your degrees of freedom. So let's say we have 12 degrees of freedom. So we've got a sample size of 13. So we're using this row right here. And let's say it's now notice up here, it's a one-tail or a two-tail area. Let's say it's a one-tail hypothesis test. Well, that's an area of 0.05. We trace that down to 12 here. It gives us a critical value of 1.782. If it's a two-tail test, alpha of 0.05 would be this column, area in two tails. That's 2.179. So you can use it that way. Now, if you want to find a p-value out of this, you can't get an exact p-value. But let's say your test statistic is 3.1, and you have, let's do 15 degrees of freedom. Well, if I'm looking through here, all these values are less than 3.1. So this here, the 2.947 is the closest to the 3.1. That's a 0.01. A bigger value would be a smaller p-value. So all you can say there is that the p-value is less than 0.01. Let's say we have 10 degrees of freedom here, and we have a test statistic of 2.00. Well, that would be between these two numbers. And if this is a one-tail test, that tells us then that we're between 0.025 and 0.05 p-value. So we don't get an exact p-value, but we can get a range that it's in, which is enough to determine whether we reject the null hypothesis or fail to reject it. So those are the tables. That's how you access the tables if the links are not given in the PowerPoints, or in the MyMathLab, I should say. You can always access it directly like this through MyMathLab.